Let's now experiment with a few more examples to get more familiar with casting. What do we see in this program? We have declared a variable a double variable, and we have made it equal to the division of two other numbers. Now, if we're just going to read this expression with just a math mind, there is nothing really important in this expression. It's a very simple expression, everything seems straightforward. However, we need to look at it with a programming mind. The division operation that is going to happen, what kind of division will that be? Will it be integer division or real division? Let's take a look at the operands and that will give us the answer. We have a double number and an int number. This means that the int will be silently promoted by Java to a real, so 2 will become 2.0, and then the division will be operated between reals. So it will be 9.0 divided by 2.0, all of them doubles, and the result will be a double, it will be 4.5, as we would expect. On the second line, we also see something that again does not surprise us at the first look. However, it's a little bit more complicated than the first sight tells us. We have a double being assigned a value. What is that value? That value is an int. And in this case, again, Java will silently promote 7 to 7.0. So the value of D will be 7.0. Excellent. We have also declared an int variable x. So let's try a few things with this variable. Suppose that we say x becomes equal to d. What will happen? This is an example of a downcast. So if, according to everything that we've said so far, this should create a compile time error. Now let me save this file and let me show you something about the Emacs editor that you might find useful if you are using Emacs as your editor. If I press Ctrl X2, that will split the frame into two windows. Ctrl X O will take me to the other window, and through Emacs, so this is actually the important thing that I wanted to show you, I can run the terminal. So far we have been using the editor and the terminal window, one next to each other. We can use a terminal through Emacs, and actually that will be making our coding more efficient. How do we do that? We do mx and then type term, and that will start a terminal on this window below. And here we can type commands like usual, javac and the name of the file. We can also use tab for autocompletion, and then see the result of the compilation. And as we would expect, Java will complain, because there might be loss of information, loss of data on this conversion. Now, again, we know that there is not going to be loss of information because D has a small value, it is 7. 7 can be accurately stored in 4 bytes, that will be X. So what we will do instead is explicitly tell Java it is okay, just go ahead and do that. We save again, Ctrl O to go to the other window. Now notice again that the shortcuts that we showed in the terminal also work here. Not only the tab for autocompletion, but also we can press the upper arrow, and that will give us the history. So when we compile this time, there is no mistake. Ctrl X O to go to the other window, or just with a mouse. What else might we want to do? Let's forget about the x variable for the moment. Suppose that we want to store, let's make a different variable, y, that is of type int again, and we want to store the value of variable a. So in a similar way that we stored the value of d, the value of a double, to an int variable, we want to store the value of a to an int variable. So we're going to say the same, explicit typecast a. Now, We don't expect any trouble with that, any compile time errors, but let's print the values of those variables. So let's create a space among them and first print a space and then print the value of y. I'm saving, and again we're using the upper arrow. We can also retype it, but there is no reason for that. We compile and then we run like we know Java casting. The value of a is 4.5 as we were expecting. The value of y is 4. No compile time mistakes. However, it's not 4.5. Well, it couldn't be 4.5 because y is of int type. So we had to, there was a choice that needed to be made. Will it be 4 or will it be 5? Always when we have casting in such a situation, what will happen is truncation. The value will be truncated, it will not be rounded up, for example. Keep this in mind. Let's now see a final tweak that we have made and how it will behave with the rules that we know. What I have done here is that I have changed the value, the expression for x. Instead of just assigning d, as we had before, I said, what if we want to divide the value of d by some number? And here we have divided by the value 3, but as a double. So it is 3.0. Now, I have also added a print line statement compared to the previous version that you saw. Now, what will the value of x be? You can pause the video, think about it, and continue with the answer. One way that we could think about it would be to say, okay, so what is going to happen is that d will first be divided by 3.0. So we have 7.0 divided by 3.0, the result will be 2.33333. That number will now be converted into an int because of the typecast. So it will be down to 2 because of truncation. So x will have the value 2. This is one way to think about this expression and the result from this expression. Let's go and compile the program and see what will happen. Although we did not expect it, we see this weird mistake. It says again that there might be a possible loss from the conversion of a double to an int. And this is the moment where we start doubting the compiler and becoming mad at the compiler, because there is obviously an explicit typecast over there, so that we're fine with the conversion from a double to an int. However, the key to resolving our confusion is the following. The typecasting is actually an operator. And it is an operator that has very high precedence. It has even higher precedence than the division operator. So the way that this expression will be evaluated is not the way that I described before, and it is probably the way that we would likely think. What will happen is that since the typecast has a higher precedence over division, this is what will happen first. So the first thing that will happen is that d will be converted into an int. So 7.0 will be down to 7. Then 7 will be divided by 3.0. Java will silently promote 7 to 7.0, and then it will divide by 3.0, so the result will be 2.3333. And then we try to assign that real number to an int variable. So the expression we have written is, as it is equivalent to saying int x becomes equal to 2. This value. That's why Java is complaining that if you want to assign this double to the x variable, you need to actually typecast explicitly. Now, one way to solve this is to actually add a typecast. Another way would be to just add parentheses and say, you know, forget about the precedence, I want what is inside the parentheses to happen first. Do not group them in the other way. Do not group D with the typecast operator. Group first D with the division operator. So now what will happen will be D 7.0 divided by 3.0, the result 2.333. That will be explicitly typecasted and it will result into the value 2. So let's again run the compiler and see whether what I just mentioned is true. The fact is that I forgot to save the file, which I don't wish it happens a lot to you too, but unfortunately it may. So we compile, things look nice. We run, and actually we do see 2 as the result.